Science is for everyone. Science is for everyone. Science is for everyone.
Sorry about that. Hello, everyone. Thank you for joining us tonight. My name is Denise Hernandez, and I help put on programs like this one at the Chicago Council on Science and Technology, or C2ST. Welcome to tonight's program, The Impact of Environmental Chemicals on Reproductive Health. This program is presented to you by the Chicago Council on Science and Tech. If you're new to C2ST, our mission is to inspire and engage all segments of society about science and tech and their contributions to society. We're really delighted to be entering our 16th year of offering science and tech programs such as this one to the public. To ask questions, please visit sli.do or Slido and enter code 508-7334 for answers during the presentation. Visit c2st.org to learn more about upcoming programs and to donate. Our staff will also check C2ST TV, YouTube Live, and Facebook Live for your questions. Again, to ask questions directly, you'll go to sli.do, sli.do, and enter code 508-7334. Again, to ask questions directly, you'll go to sli.do and enter code 508-7334. I have the immense pleasure of introducing Dr. Jodi Flaws, today's amazing speaker. Very briefly, you can learn more about them at c2st.org. Dr. Jodi Flaws is a professor of comparative biosciences at the University of Illinois Urbana-Champaign. She received a BS in biology from St. Xavier University, an MS in biology from Loyola University of Chicago, and a PhD in physiology from the University of Arizona. Following completion of the PhD degree, Dr. Flaws performed postdoctoral research at Johns Hopkins University and the University of Maryland. Following postdoctoral training, Dr. Flaws accepted an assistant professor position at UIUC. In 2006, Dr. Flaws, In 2006, Dr. Flaws accepted a position as a professor of comparative biosciences at the College of Veterinary Medicine at the University of Illinois Urbana-Champaign. Please join me in welcoming our speaker, Dr. Jodi Flaws. Jodi, I'll hand it off to you.
Yeah. Hi, good evening, everybody. Can I please have the slides? So what I'd like to do tonight is talk to you about the effects of chemicals that we call endocrine disruptors on female reproduction. What I'd like to do in today's talk is to first give you just a tiny bit more background on who am I and how did I get here? What does my lab research? Which environmental exposures are associated with reproductive toxicity? We'll talk a little bit about how chemicals cause damage, and then end with what we can do to prevent damage from chemicals. So I know that Denise already gave some background, but I just want to emphasize a few things that tell you a little bit about my background and how I got to be a scientist researching what I do. So I grew up on the southwest side of Chicago in a neighborhood called West Lawn. This is actually the house that I grew up in. It's not too far from Midway Airport is here. Then I went to undergraduate and got a bachelor's degree in biology from St. Xavier University. I was really interested in science. So after completing my bachelor's degree, I got a master's degree from Loyola University. And then at this time, I knew that I wanted to be a researcher and a professor, and I knew that required a PhD. So I went to University of Arizona, where I got a PhD in physiology and toxicology. Following that, I did some postdoctoral training at Johns Hopkins University so that I could really develop my research skills, and then began a faculty position at the University of Maryland in Baltimore. But then in 2006, I was fortunate enough to be able to come back home to Illinois, where I was, now I'm a professor in the College of Veterinary Medicine in Urbana-Champaign at the University of Illinois. My current lab is made up of many people who help conduct the research that we do. Some of these are people that have PhDs already and are conducting research. Others are students who are obtaining their PhD or master's degree by conducting research in my lab. And I also have wonderful undergraduate students in my lab who are very active in research. And I just wanted to really briefly mention two things for people that are really interested in STEM and maybe interested in research in this area. We have two fantastic programs at the U of I. One is a PhD program for interdisciplinary environmental toxicology program. So if you happen to be somebody interested in a PhD, I highly encourage you to look into this program. And then we have a wonderful undergraduate research program called SureTox, or Summer Undergraduate Research Experience in Toxicology. And this is a program specifically designed for a diverse group of underrepresented students who want to conduct research in the summer. And this program pays a stipend, pays for tuition, housing, and food. So if anybody's really interested in gaining more research experience in the field I'm going to talk about, please look into that program as well. So my lab is really focused on an area called reproductive toxicology. And the questions we address are which environmental chemicals adversely affect reproductive function. And then we want to know, how do these chemicals cause damage? Because by understanding which chemicals cause problems and how they do it, we'll then be able to better develop ways to protect people and wildlife from harm of some of these chemicals. Now, I want to highlight just some of the environmental chemicals that we know can cause harm to the reproductive system. And I've put this list here of broad categories of chemicals that I want to give examples of from each of them. So I want to talk about pharmaceutical agents, pesticides, flame retardants, plasticizers, and then a group of chemicals called environmental contaminants. So I like to first give an example of a pharmaceutical agent that we know can cause harm to the reproductive system. And I give this example of a drug called diethylstilbestrol, or DES. And this is a classical example in the field in which pregnant women were given this drug during pregnancy. And it was given to women who were having what physicians called a difficult pregnancy at the time. So these women were at risk of having an abortion or miscarriage or premature labor. And this was occurring in the 1950s, 1960s. DES was heavily prescribed, and it was being touted as being effective and safe. And it was thought that this chemical, given in massive doses, was safe and would provide optimum therapy for maximum safety. And in fact, many pregnant women took this drug at levels of 275 milligrams a day. And to give you some context, this is about anywhere between 1,000 and 10,000 times higher than the types of chemicals that are present in today's oral contraceptives and other drugs that have similar structures. So what happened was pregnant women took this drug and they seemed fine. And when they gave birth to their children, those children seemed fine. However, between 1966 and 1969, physicians began to notice, and in one particular clinic, there were 8 patients that showed up that were between 15 and 22 years of age that had vaginal cancer. And this is a really rare type of cancer, and the number actually should have been 0. So when the clinicians began to look into what was happening here, they realized that 7 of the 8 patients were born to mothers who took this drug, DES, during pregnancy. And it's really pretty likely that the one other patient was born to a mom taking DES. They just couldn't document it. And so from the late 60s ongoing to today, people have been studying these children that were born to mothers who took DES during pregnancy. And we know that these children have serious adverse outcomes in both the male and female reproductive system. And because of that, the use of DES worldwide is really limited. And in fact, it's primarily not manufactured in the US. And so just to give you some examples of what happened in these children. So the female children were born with abnormalities of the reproductive tract. So their uterus and fallopian tubes were misshapen. And because of this, a lot of these females had infertility. Those females that were able to get pregnant did experience preterm labor, often resulting in early births of their children. Many of them developed things called fibroids, which are non-cancerous tumors in the uterus that can cause abnormal bleeding and pain. They had lots of cancers of the vagina, but also the breast. And then if these daughters of the DES moms went on to have children, we now know that many of their daughters have some of these same abnormalities. And these are referred to as DES granddaughters. So grandma took the DES during her pregnancy. Her female children and their female children have many of these abnormalities. Now, it wasn't just the female children that were having issues. A lot of the male children experienced something called cryptorchidism, which is failure of the testis to descend outside the body cavity. And in humans, it's really important that the testis is outside the body cavity, because if it isn't, it gets too warm, and then the testis doesn't make the proper amount of sperm or normal semen. So a lot of these boys had abnormal semen, and because of that, they had reduced fertility. And also when the testis is inside the body cavity, that often leads to testicular cancer. So many of these boys had testicular cancer. And then another condition that they had is something called hypospadias. And this picture here is showing an example of one. So this is the penis, and what happens is the urethra, or the opening for urine, is at the base of the penis instead of the tip of the penis. And this is a very painful condition that can lead to infection and pain and needs to be surgically corrected. And just like we saw DES granddaughters, these boys, if they went on to have children of their own, often their children had a lot of these same abnormalities. So this story of DES is a really important one in toxicology, because we unfortunately learned many things from it. So prior to this, there was a lot of thought that pregnant people will have a placenta, and that placenta should protect the fetus. But we know from DES that that placenta does not always protect the fetus. And so we really must use care with drugs that people are taking during pregnancy. DES is a chemical that mimics a normal hormone in the body called estrogen. And at this time in the 50s and 60s, it was thought that if a little estrogen or estrogen-like chemical is good, that massive amounts are even better. And we learned from DES that that is not true. Not all estrogen-like compounds are good for all tissues or all species. We learned that chemicals can have delayed, long-lasting effects. So when the babies were born to the moms taking DES, they looked perfectly fine at birth. It wasn't until they hit puberty and began to develop reproductively that these effects of DES started to be seen. And we also learned that chemicals can have what we call transgenerational effects, meaning these effects are passed from one generation to another. So in the case of DES, a pregnant mom took DES, her children, and then their children had some of the bad outcomes from the drug. So the next group of chemicals I want to talk about are called pesticides. And pesticides are heavily used on crops. They are used in our homes because we don't want to have cockroaches. And they're also used as flea and tick preventatives. So they have many good uses in our world. But we know that many pesticides also have toxic effects. Some pesticides have been heavily banned because of their toxic effect, and those banned pesticides have been replaced by newer pesticides, several of which we now know have some toxicity. And because these pesticides are heavily used on things such as crops, lawns, gardens, home, and pets, they don't stay in those particular areas, and they actually leach out of them, and they can contaminate our food and water supply. And then we as humans are exposed through our food and water, and wildlife is exposed also through their food and water. And we know that many pesticides are what we call known reproductive toxicants. And some examples are, there's a pesticide called DDT, which is banned in this country. And it's banned because it started to cause a lot of eggshell thinning in birds. And in fact, back when I was a student in Chicago Public Schools, we learned a lot about DDT because it was causing a massive decline in the eagle populations across the United States, because it was causing their eggshells to thin, and then the birds were not allowed to develop properly. And we've since banned DDT, and now I'm happy to say that the eagle populations have come back in many, many places. That same chemical can cause abnormal reproductive organs in alligators, and I'm going to show you an example of that. In humans, DDT, as well as other pesticide exposures, can cause spontaneous abortion or early miscarriages. A condition called endometriosis is where the lining of the uterus starts to grow outside of the uterus, and this can often lead to inflammation, pain, and infertility. Low conception rates or low ability to get pregnant, and also infertility. And the one example I want to give about pesticides is an example from Florida. So this is the state of Florida, and I've circled here in red different lakes in Florida. There was a lake, or there is a lake called Lake Apopka, which is sort of in the center of the state, where scientists noticed that alligator populations were heavily declining in that lake, but not in some of the other lakes. And so they wondered, what is going on with the alligator populations? Well, they figured out that pesticides were getting this area surrounded by farms. And so a lot of pesticides from the farms were getting into the lake. And those pesticides were causing abnormalities in the reproductive organs of the alligators so that they could not mate properly, and thus they were not able to reproduce. And it's actually turned out to be somewhat of a success story, because once they figured this out, they cleaned up the lake, removed a lot of the pesticides, and the alligator population has come back in that lake. Now, another category of chemicals that are of concern are chemicals called flame retardants. Now, these are chemicals that are put into products to avoid them from catching fire, or if they do get on fire, they don't burn up really quickly. So they're in products such as televisions, clothing, furniture upholstery, computers, carpeting, and car upholstery. The problem is twofold. So they're actually not that good at preventing flames. And two, they don't stay in these products, and they actually leach out where they get into our air and water, and then humans are exposed and wildlife is exposed. So there are studies on animals such as polar bears in Antarctica, where these polar bears have pretty high levels of flame retardants, despite the fact that they're not sitting on furniture, having carpeting, anywhere near any products that have flame retardants. So we have enough of these that we're putting into the environment that they're being transported across the world and ending up not just in people, but also in wildlife. And I want to give one example of what these flame retardants are doing to some species. So this is the map of the United States. And if you look around the coast, I've got red and yellow dots here. So the yellow dots are indicating where there are pretty medium levels of flame retardants. And the red dots are areas with high levels of flame retardants. And if you notice, that's really almost around all of the coast and around the waterways, the Great Lakes, and then the Atlantic and Pacific Oceans. Now, in these areas, there are birds, including birds called American kestrels, where we're now seeing that these birds are having reduced eggshell mass, they're having delays in their egg laying, and reduced fledgling success. So these bird populations are declining. So it's a very similar situation to what I talked about with DDT and the eagle populations. We're now seeing that these flame retardants may be responsible for reducing birds such as American kestrels. Now, a huge group of chemicals that I want to talk about are called plasticizers. And these are chemicals put into plastics to keep them sturdy yet flexible. And one type of plasticizer are chemicals called phthalates. So phthalates are used in plastic food and beverage containers, children's toys. They're in the IV tubing and medical blood bag, polyvinyl chloride pipes, wipes, heavily used as solvents in personal care products, makeups, nail polishes. They are used in air conditioners or like scented air fresheners. And they're also used in things such as lotion, shampoos, and conditioners. Now, we use a lot of phthalates. In fact, more than 18 billion pounds of phthalates are produced worldwide each year. The Center for Disease Control has identified phthalates as one of the top 3 contaminants present in people. The other ones are pesticides, which I talked about. And then the third one is another plasticizer called bisphenol A. Now, because we use so many of these phthalates in plastics, and high levels are in plastics and microplastics, a lot of the phthalates are leaching out of these plastics into our food and water. And they're actually, because we've got plastics in the ocean, they're in the ocean, and phthalates are contaminating wildlife species as well. Now, we know from many studies, including studies that my lab has done, that these phthalates are leading to a decline in the number and the quality of sperm that men have. And because of this, it's leading to declining fertility in men. And in females, it is also affecting the eggs and the ovary, which we need healthy ovaries and eggs for fertility. And so there's been a decline in fertility in females as well. Now, bisphenol A or BPA is the other plasticizer that is one of the top 3 contaminants in humans. Now, this particular chemical was originally made in 1891. And it was developed by a pharmaceutical company, and it was going to be given to women, pregnant women, at that time to prevent miscarriages. However, at the same time, diethylstilbestrol or DES, which is the first chemical I talked about, was developed, and it was determined that that was actually a more potent chemical. And DES was used pharmaceutically instead of BPA. And we know that's been not a good scenario. For reasons that I'm not really clear about, BPA, it was determined by plastic manufacturers that if you made plastics that contained BPA, it made them flexible yet sturdy. And so the primary use of BPA has never been as a drug, a pharmaceutical agent. It's always been as part of plastics. And because of that, BPA is literally everywhere. So it's in plastic food and beverage containers. If you look inside canned fruits and vegetables and you see a white liner in there, that liner is there to prevent food from rusting out of cans, but it contains large amounts of BPA. If you've ever had your teeth sealed, that sealant contains BPA. It's used in plastics to make night guards and retainers and baby bottles, and it's used as a coating in thermal register receipts. Now, the problem with BPA, and particularly when it's used in polycarbonate plastics, is that it does not stay in those plastics. So when those plastics are exposed to light or heating, such as heating plastic in a microwave, or aging if the plastic becomes old, or if you clean it with cleaning products, those products have acids and bases in them, and it causes that BPA to leach out of the plastic. And we know from many studies that this is a concern because BPA exposure, when it gets into our food and drink and humans consume it, it can cause ovarian cysts. It can alter the menstrual cycle, interfere with the ability to ovulate or release an egg, leads to early onset of puberty. Some people may have heard that the age of puberty is declining across the world, and particularly in the US. Some of that is likely due to exposure to BPA. BPA is also a chemical that we call an obesogen. It increases weight gain, and it also leads to premature development of the mammary glands. And then lastly, I'd just like to talk about a group of chemicals called environmental contaminants. Now, these are chemicals that are in our environment that weren't made for a specific reason. They're actually unfortunate byproducts of making other chemicals. And some of the most toxic chemicals that we know about are called dioxins. And one example is a chemical called tetrachlorodibenzodioxin, or TCDD. Now, these compounds are contaminants after our bleaching of paper or when we make pesticides and herbicides. And some people may have heard about in the Vietnam War, they sprayed a chemical called Agent Orange, which was an herbicide that was being sprayed across fields in Vietnam. Unfortunately, Agent Orange was contaminated with dioxins. So a lot of the Vietnam veterans and Vietnamese people that were exposed to Agent Orange during the Vietnam War, some of the adverse effects they have were because that agent contained dioxins. Now, dioxins have been shown to affect reproduction in humans. It leads to birth defects and to endometriosis and causes a very painful, extreme acne condition called chloracne. And animals that are exposed to dioxin, it causes malformations of the reproductive tract, decreases sperm counts, delays puberty, causes endometriosis in primate animals, and affects behavior, decreases reflexes, increases locomotor activity, and causes something called the wasting syndrome, where the animals really lose a lot of weight and become very sick and die. And I'll just show you some examples. So these are people that were exposed to dioxin during the Vietnam War. This is chloracne. This is this very painful, inflammatory acne skin condition. And these children were exposed to dioxin when in utero. And so they were born with tremendous birth defects. And then another example is in 1976 in Italy, there was an industrial plant that had a broken valve, and this caused an explosion. And because of this, this plant released about 3,000 kilograms of dioxin into the atmosphere. And it was released in these big clouds called dioxin clouds. And this was referred to as the dioxin disaster in Italy. And so what happened is these clouds in the area, they exposed animals to the dioxin. So a lot of farm animals, cows and sheep and people's pets all had this wasting syndrome and died from this dioxin exposure. And then the last chemical I want to talk about are environmental contaminant known as polychlorinated biphenyls, or PCBs. Now, these chemicals were banned in the 1970s. Prior to that, they were used in electrical transformers, capacitors, hydraulic fluids, plasticizers, and adhesives. The problem with PCBs is they do not degrade in the environment, and they persist in the environment, and even today they persist in fish. And this is just to show you an example of the levels of PCBs in fish from our 5 Great Lakes. And the green line here is the line that the EPA says PCBs should be below to protect wildlife. And if you'll notice, all of the Great Lakes, including our Great Lake, Michigan, are well above this level. And so we know that these PCBs are in fish, and we know that humans are exposed because PCBs are in fish and in the water and in our environment, and animals are also exposed. And in humans, they can cause reproductive problems, growth retardation of the fetus, and birth defect. They cause problems with the nervous system, impaired short-term memory, and delayed psychomotor development. And they interfere with the thyroid gland, and the thyroid makes hormones that control metabolism, the nervous system, and reproduction. And similarly, in animals, they affect reproduction by decreasing litter size, causing spontaneous abortions, early puberty. They cause cognitive defects and affect the thyroid. And so one thing that is common among all of these chemicals I talked about is they disrupt the reproductive system in a similar way. So the reproductive system is part of a larger system called the endocrine system, which makes hormones that control many aspects of the body, including reproduction. And all of these chemicals do what we call endocrine disruption. They either mimic hormones and act like a hormone when one shouldn't be there, or they block hormones from acting. And this triggers inappropriate hormone action, leading to a lot of these bad side effects that I told you about. And so I don't want to end on a note just saying, you know, these chemicals are of concern. So I want to just end with saying, what can we actually do to avoid this endocrine disruption? So I think at a global level, it's important to change and create policy to really do a better job of screening and regulating chemicals. This is largely done by the EPA and FDA, cleaning up the environment, funding research so that we really understand the mechanisms by which these chemicals cause damage so we can develop treatments. And then on a grassroots level, I feel like it's important to be aware of these things, because I think then people can make choices about their exposure by limiting use of products containing harmful chemicals, cleaning up the environment, and either conducting or participating in research, whether it be at the environmental level or the university level, to really try to develop ways to prevent and treat some of the diseases and disorders from this kind of chemical exposures. So in summary, I'll leave you with that we are exposed to many environmental chemicals, and that these environmental chemicals can affect reproduction in wildlife, pets, and humans, and that we really need more studies to determine which chemicals affect reproduction and how they act, so that we can make better policies as far as prevention and treatment. And so with that, I will thank you for your attention, and I'm happy to answer any questions.
Jodi, thanks so much for sharing that really important information with us and for your talk. We have quite a bit of questions, so if you're okay, let's get right into it.
Thank you.
One of our attendees asks, I've heard about microplastics being found in breast milk. What kind of effects can this cause? Can you speak on this at all?
So I think that's a fantastic question. And the audience member is correct. These microplastics have been found in breast milk. I think that it's too soon to know the effects. I think these kind of studies are just starting now. But we do know that a lot of the chemicals that are in microplastics, such as bisphenol A or phthalates, those chemicals can be transmitted through the breast milk to the baby. So it is likely that some of those chemicals are getting from the breast milk to the baby. The part that we don't know is what are going to be the long-term consequences for the baby.
I see. That reminds me of something you mentioned in your talk about the persistence of PCB in fish. Is it a similar system as well about the transfer of those effects and chemicals?
Yeah, so PCBs for sure are found in breast milk. And there have been many studies in populations where they eat a lot of PCBs concentrate up the food chain. So the larger, bigger fish have higher levels of PCBs. And so in populations where they eat large amounts of big fish, such as some Inuit populations, those PCB levels in pregnant people are high, and then they're high in breast milk. Mm-hmm. And we know from many studies that those PCB levels are contributing to some cognitive deficits in those children. So for sure, that's an example of a chemical in breast milk that is harming the children that are exposed to it.
I see. That's a really great segue to the next question. Someone asks, when a new drug or pesticide comes out, can we test for these types of effects before they are released, or do we have to wait and see?
Yeah, so in many countries and a lot of times in the US, we don't use the precautionary principle. So many chemicals are put on the market and assumed to be safe. And the reality is there are so many chemicals that it's not possible to test every single one before it goes to the market. So I don't think we can assume just because a chemical is on the market that it's safe. It may not have been tested, or at least tested for some of the endpoints that where we might see harm. And so we don't always know whether a chemical is going to be safe, and sometimes we have to wait and see. Sometimes we can predict that it's not safe based on its chemical structure or similarity to other chemicals that are not safe. But then sometimes there's a risk benefit where they'll say, well, this chemical might pose a risk, but we really need to use it for these reasons. So it's really, really difficult. And there's thousands of chemicals that need to be tested, and not really good high throughput mechanisms of testing them all in a quick manner. So it takes a very long time before we sometimes get the information that we need.
I see. You talked a little bit about transgenerational effects in your talk. When someone asks, are there any transgenerational effects from drugs and chemicals that are beneficial? Can this happen with vaccines?
So I don't have expertise in vaccines, but my understanding is really unlikely. I don't know of any evidence where some of these more beneficial drugs cause these transgenerational effects. The problem with DES is its chemical structure makes it one of these endocrine disrupting chemicals. And oftentimes what those chemicals do is they change the DNA in a way that abnormal structure and abnormal genes can kind of get transmitted from one generation to the next. And a lot of regular pharmaceutical drugs that we use on an everyday basis, they don't do that. So I don't think, I at least personally am not concerned about a lot of drugs that we use on an everyday basis causing these kind of transgenerational effects. I'm more concerned about chemicals such as DES or things that have the same kind of structure leading to that.
Yeah, so your answer to the previous question, you mentioned a little bit about the logistical sort of hurdles and making sure that new chemicals or pesticides don't have these negative effects. But someone is asking, how can the average consumer avoid these chemicals in their products? And I know you talked a little bit about that towards the end of your presentation.
Yeah, so it is hard. I think one thing, like what I usually do, is I try to be aware as much as I can about what kind of chemicals potentially cause damage. So, for example, I know some chemicals in plastics, and so what I do is, and it's not possible to completely eliminate plastic, but I try to limit using plastic products as much as I can. If I do use plastic, I don't reuse old plastic. I don't ever heat anything in microwave. I try to really limit using canned products because of that. So I think it's not possible to completely eliminate our exposures, but I think trying to reduce it by just being aware that there are some things that we can never eliminate from our environment, but we have to reduce our exposure.
So I know that we've been focusing a little bit on effects on humans, and then you also talked a little bit about the effects on animals and wildlife. And for those of us who have fur babies and animals at home, can these chemicals have an adverse health effects on pets, like those found in flea and tick preventative products?
Yeah, so this is a case where it's really a risk-benefit thing. So I would never say that somebody should not use flea and tick preventatives, because I feel like the benefit of your pets not having fleas and ticks far outweighs anything. And a lot of the flea and tick preventatives don't contain some of the chemicals that we know can cause some of the damages I talked about. There are some that are much safer. And for the most part, so I'm just going to take it from a perspective of dogs and cats. So many dogs and cats are spayed and neutered, right? And so the concern about reproduction or affecting their ovary or their testis is a lot less. So if they're using a flea or tick preventative, and if your animal is spayed or neutered, it's not going to be possible to be affecting the ovary or the testes and causing some of these effects. But I think the benefit of using those products far outweighs some of the risk that you would have.
I see. Yeah, I never thought about that most pets are spayed and neutered, so that makes a lot of sense.
What I would say, though, is for people handling those products, I would just make sure to wash your hands really carefully after handling, because, you know, the product, we can get some of the pesticide that's used in those preventatives into us, and then it could, you know, if it's high exposure over long periods of time, could cause a problem. But just, you know, a one-time exposure, limited exposure, I don't think we have enough data to say that that's going to be a problem.
I see. So towards the end of your talk, you did mention, you touched a little bit on policy, and I know that's obviously is not your area of expertise, but someone is asking, can science-backed legislation help to make sure chemicals and products are safe? I'm not sure if you could speak on it, but any sort of thoughts on that?
Yeah, no, absolutely. And I'm not as involved in it as some of my colleagues, but there are scientists working in a lot of these government agencies. There are a lot of non-government agencies that are made up of scientists who are really there to try to use scientific data to help craft legislation and to talk to legislators to try to get them to put policies in place to protect us better. And so absolutely, it's a place where science can work with policy, and a lot of scientists are policymakers and working with legislators to do that.
That makes me feel really good. I know a lot of this is sort of like doomy, like, oh my God, what's going to happen to my body? So that's really reassuring.
Chicago's got a very successful example. So bisphenol A, which is one of the plasticizers, is heavily used in baby bottles. And that was a concern because leaching out and then getting into babies. And Chicago was actually, you know, working with scientists and legislators. I believe it was one of the first cities to ban BPA in baby bottles. And so it's a very successful interface of legislatures, you know, on a local level, also working with scientists on a local level to get that done.
That makes me feel really good. So going a little bit back to talking about animals, someone is asking, do we tend to see more effects in animals than humans because they're smaller, or because they are fundamentally different than us?
So I think it's probably a little bit of both. Well, it probably depends on several things. So sometimes it has to do with more exposure. Sometimes it has to do with, a fairly high exposure and a fairly small body size. There are some differences in how we metabolize chemicals and how animals metabolize chemicals. So there are many things that can contribute, length of time of exposure. But in many cases, there are a lot of similarities. So the endocrine system is highly conserved among species. And so a lot of chemicals that disrupt that system in animals will do the same thing in humans. And so I don't think we can just say that it's always going to be different between animals and humans, or one's going to be more sensitive than others as far as species. I think it really just depends on a lot of factors, including the dose, the length of time of exposure, age of animals and age of people, that can often create a different sensitivity.
We have a really interesting question here. Are silicones considered plastics? I know silicone is kind of everywhere as well.
Yeah, so that's a great question, and I actually don't know the answer to that. So like in my research, and when I think about plastics, I don't think about silicone, but it raises a question like, how do you actually define a plastic? And so I wish I had an answer, but I don't know. And I'm trying to think, like, is anybody really studying silicone and kind of the adverse effects of it? And I'm sure people are studying that, but I'm just not familiar enough with those studies to speak about them.
I see. Yeah, it's one of those things that I'm sure you've not, some folks don't think about often. So we have a question about your career. And before I ask this question, I just wanted to say I actually live in West Lawn and partially grew up here, so it was really awesome to hear that you grew up in this part of town.
I grew up on 68th and Pulaski, right near there. So.
Right off 66th. Oh, that's Do you still have family over here by chance?
Pardon me?
Do you still have family over here by chance?
No, they've all moved either to like suburbs or more downtown.
Okay. I see. Well, shout out to West Lawn.
Yes.
This question asks, why did you start studying this area of science?
Yeah, so I think that when I went for my master's degree at Loyola, my advisor was a reproductive biologist, and we worked on reproduction, and I just was really, really interested in. And then when I went to University of Arizona, my PhD advisor had just started a project looking at a chemical used in rubber manufacturing. And it was really my first exposure to toxicology. And I just found it really, really interested. And I learned more and more about toxicology and never looked back. And it really wasn't until I was in graduate school that I ever even heard of toxicology or ever even heard of anything related to this field of environmental health. And it's mainly for that reason, the summer program that I run, that's really designed for undergrads to get some experience in toxicology. It's so that students have an opportunity to learn more about the field, because I just didn't have that opportunity as a student until I got to graduate school.
Can I ask what, as someone who's done very extensive research in lab, what are the questions that are in your field and perhaps in your group? What are the questions that you're really itching to answer?
So the latest thing we've been working on are some pesticides called neonicotinoids that are used as seed treatments. And they're heavily used, particularly in Illinois, because they're in corn and soybean seeds. And they're also a heavy component in flea and tick preventatives. And I'm in a vet school, so there's always lots of interest in that. And so what we want to know is whether these chemicals are harmful to the reproductive system. And then the other chemicals that we've been working on, phthalates and bisphenol A, we know that those chemicals can cause what we call early reproductive aging or early menopause. And so we know this from animal studies, but what I'm really dying to know is whether this happens in humans. So we're conducting a research study with humans who are going through menopause and trying to see whether these chemicals are affecting how they experience menopause and the age at which they experience menopause.
Well, speaking of Illinois, someone is asking if PCB sticks around forever in the environment, is it possible to remove them from Lake Michigan? Are PCBs in Lake Michigan?
Yep, so they're in Lake Michigan, and they're actually in pretty high levels, or at least levels that are above the EPA safe level. So they do degrade, but it takes decades. So the levels have been going down. There are chemists and other environmental scientists that are working on ways to try to clean them out of lakes and rivers and other places they exist. And so there's hope, but it's slow going, and we haven't gotten quite to the point where we can easily remove them. So the best way to prevent it is to not keep putting those into the environment, these kind of long-lasting, non-biodegradable chemicals.
I see. I had no idea they were in the lake. That is even more concerning.
Yeah.
Well, it looks like we have one more question, and it sounds like it'll be a nice way to wrap up. How can someone get experience in science field work, especially outside of a university?
So outside of the university, I would say to look up in your local area nonprofit organizations, things such as Greenpeace or the Environmental Defense Fund or places like that. If you kind of search online, environment and non-government organizations or non-academic, there are a lot of grassroots groups that are really involved in research, either at a community level or at an environmental level, or even a laboratory-based level, that people can get involved through those ways.
Awesome. Well, thank you so much, Jodi, again, for sharing your insight and knowledge in a way that such that we could all learn about endocrine disruptors and reproductive health in an accessible and simple manner. We really appreciate it.
Well, thank you for this opportunity, and I hope everybody has a wonderful evening, and thank you.
So please evaluate today's session at sli.do, sli.do, and enter code 5087334. On the top right, there will be a poll section, so just please click that and be entered to win a gift card. To support more programs like this one, donate at C2ST.org and consider giving $16 in celebration of our 16th year. Woo! Sign up for the weekly C2ST newsletter to stay up to date on what's happening in STEM. Thanks for sticking around to the end of tonight's program. We hope you learned something new. If you enjoyed what you just watched, please like this video and subscribe to our channel. You can even hit the bell icon to be notified when new videos are uploaded. And if you really liked the video, please leave a comment below. Thanks for watching, and thank you for joining us tonight.